Welcome to the third segment of Full Wave Rectifier.
In this segment, we will discuss about the ripple factor, efficiency, form factor, and peak value of the half wave rectifier. So let's get started. Before we get into the mathematical portion, let's revise the definitions first and their significance. Efficiency. Efficiency can be defined as the ratio of DC output power to the AC input power. But why is efficiency required for half-wave rectifier? Efficiency measures how efficiently the half-wave rectifier rectifies the AC component to its DC component. The higher the efficiency percentage, the better it works. Form factor. This is defined as the ratio of IRMS value of the output voltage to the average value of the output voltage. But why is form factor required? Most of the AC multimeters are designed to display the RMS value of a sine wave. Since it is nearly impossible to achieve the RMS value digitally, hence the absolute average value is calculated and the result is multiplied by the form factor. It is generally preferred if form factor is equal to 1. Peak factor. This is defined as the ratio of peak value of the output voltage to the RMS value of the output voltage. But why is peak factor required? Peak factor is used to determine how extreme the peaks are in a waveform. A peak factor of value 1 indicates a waveform of no peaks such as a DC output or a square wave. Ripple factor. The ripple factor can be defined as the AC component within the DC output. But why is ripple factor required? Ripple factor is used to measure the effectiveness of a rectifier circuit. As we have discussed earlier that the ripple factor of a DC output of a full wave rectifier is eliminated using a filter circuit. Hence, we can come to the conclusion that the lesser the ripples, the better the performance.
Let us look at a full wave rectifier. V is equal to Vm sin theta is the AC voltage that is rectified using a full wave rectifier. Rf is equal to forward resistance of the forward bias diode which conducts current at each half cycle. RL is equal to load resistance of the center tapped full wave rectifier. The instantaneous value of the current is given by the equation I is equal to V by Rf plus RL. Now since we know, therefore we can say I is equal to Vm sin theta by Rf plus RL. We also know that I is equal to Im sin theta or Im sin theta is equal to Vm sin theta by Rf plus RL. Now when sin theta is equal to 1, then current is maximum. In this case, we can rewrite the equation as Im is equal to Vm by Rf plus RL. Since the output is obtained across RL, DC power output is equal to I square DC RL. DC power output is also equal to I square average RL, where I average is equal to integration of I d theta by pi, which is equation 1. Now integrating equation 1 from 0 to pi, we get the equation as I average is equal to 0 to pi I d theta by pi, or I average is equal to 1 by pi integration of Im sin theta d theta, or I average is equal to Im by pi integration of sin theta d theta, or I average is equal to Im by pi minus of cos theta, or I average is equal to Im by pi minus of minus 1, which is equal to I average is equal to 2Im by pi, or IDC is equal to I average, which is equal to 2Im by pi. PDC is equal to I square DC RL, which is equal to 2I square m by pi square whole multiplied by RL. AC input power is given by PAC is equal to I square RMS multiplied by RF plus RL, or IRMS is equal to root over of integration of I square d theta by pi, or IRMS is equal to root over of 1 by pi integration of I square m sine square theta d theta, or IRMS is equal to root over of I square m by pi integration of 1 minus cos 2 theta by 2 d theta, or IRMS is equal to root over of I square m by 2 pi whole multiplied by integration of d theta minus integration of cos 2 theta d theta, or IRMS is equal to root over of I square m by 2 pi whole multiplied by theta minus sine 2 theta by 2, or IRMS is equal to root over of I square m by 2 pi multiplied by pi minus 0, or IRMS is equal to Im by 2, or PAC is equal to I square RMS whole multiplied by RF plus RL, or PAC is equal to I square m by root over of 2 square whole multiplied by RF plus RL. As we know, rectifier efficiency can be defined as rectifier efficiency eta can be given as PDC by PAC, or eta is equal to 0.812 by 1 plus RF by RL. Now let us consider that RF is neglected as compared to RF for maximum efficiency, or eta max is equal to 0.812 or 81.2%. Now let us calculate the form factor and peak factor. Form factor, as we know, this is defined as the ratio of IRMS value of the output voltage to the average value of the output voltage. Form factor is equal to IRMS value of output voltage by the average value of output voltage, or form factor is given by 1.11. Peak factor. This is defined as the ratio of peak value of the output voltage to the RMS value of the output voltage. Peak factor is thus root 2. Ripple factor. Ripple factor of the full wave rectifier is the ratio of RMS of AC component to RMS of the DC component in rectified output, or ripple factor is equal to 0.48. In today's lecture, we have learned efficiency of a full wave rectifier, form factor of a full wave rectifier, peak factor of a full wave rectifier, and ripple factor of a full wave rectifier. With this, we are at the end of this lecture. We will meet again in the next lecture. Till then, learn and practice. Thank you and goodbye.